we are using create parquet on NFS a Python file to create a parquet files on NFS. Let's look at the file here. So we are creating a session builder here. Master is yarn and executors we are using 1, and then we are using Spark range program to create a random rows and one table with columns. Same thing for the other columns. So here we are doing cross join between these two tables. Now we are creating a parquet files using write mode override parquet in this location. So let us use the scripts to run these create program. So in this one you can directly use the without for loop also you can use, but for demo purpose I'm using for loop. I can use the number just like a 5. I can use 1 2 3 4 different executor memory. So here number of executors is 240 because we are using 6 node cluster, and then I'm just assigning some variable for 6 node statistic collection, and the number of nodes just a variable assign some variables here. Just going to make something called demo. These variables are for the 4 node and 2 node. This is for 4 node executor changes because each server has 40 CPU and 240 GB RAM. So in this cluster we are using 6 nodes. So 4 nodes are, and I can swap memory issues are there. I can clear that cache memory issue, swap issue. I'm logging to resource manager, and this means 6 nodes are there. Each node has 241 GB memory and 40 core CPU. So 6 servers we are using 6 servers, so 240 cores are available, total cores, and here total cores are available, and 1.42 terabytes of memory is available. So based on that in mind, we are using 240 executors. When you are using 4 nodes, we change the executors to 160. 2 nodes, we change the executors to 80. And then here we are making the executor memory is 5 and executor cores 5 here, and local Spark local directories I'm mentioning this location, and executive conf location is here because that is required. Executive Hadoop conf car is a required parameter for PySpark. And here these scripts we are using clearcache.sh scripts to clear the cache in all the servers. So look at here, 151 to 156 in this order. We will connect with these servers and we'll free up the memory, sync, and echo 1 to this drop cache, and drop cache is 2 also we are using here, and 3 also we are using here, and we are swapping off and swap on just to clear the cache from the servers before we run the test cases. And then here on enmon, so enmon is to collect the enmon results from all 6 servers, 151 to 156 servers. We are collecting enmon for 900 count. It's close to 3 hours of time, 3 to 4 hours timeline. We are collecting enmon results. So in the demo at the end we will see the some sample enmon results. Enmon, this is a location we are collecting the details, and then see every 10 seconds once we are collecting 900 counts. We are also collecting the IO stat, same thing here, and then stored in this location. So mostly we are using enmon. IO stat is just for the data collection perspective. So now next one is statistics so periodic. So we made a SSH passwordless SSH to this storage controller. This is all-class A800. So I'm just taking an example. I just want to show you that how we are configuring. Oh, sorry. This is our controller. So we currently directly log in. This is 700 controller. So we are collecting the details, statistics so periodic through the scripts. So that's what we are using this here. It's updated the details here, and in this one we are going to use create Spark on create parquet on nfs.py file, which we already saw just before. We'll look into that again one more time. So here it's a Spark machines, Spark Python query. So we are going to create the file here. Let's take an example. Just taking a file location change to the new location. A800 is the location here. So if you look at that, so in this A800, so we mounted this A800 from different server locations, different IPs of A800. So this IPs 120, 121, 122, this and all these IPs are coming from A800. So here in this is A700, let's go to A800. So in A800, these are the aggregates, we are having it here, and these are the drives assigned for node 1 SSD and node 2 SSD. Going to volumes, this is the A800 volumes we are using. So these are the aggregates we are using for this. Then it's exported like this. So we can also view the performance of that particular volume when we create the parquet files. In addition to that, so we are going to change this parquet files. This is the one we are going to use it. I'm going to use this program to create parquet files, and we have the execute memories and executors, number of executors, everything is defined here. And we are also going to, after finish the operation, we will kill the enmon and IO stat as well as statistics so periodic commands also we are killing in all the servers. So let us run. Before we run it, I just want to make sure that this cluster is up and running, it's clean. There are some issues here. Just for the sake, I'm just restarting the cluster to make everything green. So all the HDFS service, it's in progress, starting. So Keeper also is doing. You can see the in progress status here. So when it is starting, I just want to see what is the cluster version details. Pulses, you can go there, it will show you what are the pulses usage. Selection. So this is the CDH version 6.3.4 we are using for this testing. It seems everybody, all the services are up and running. Check the Hadoop's resource manager. There is no running process. So 240 cores and 1.42 GB, 42 terabytes of memory available. Okay, so let's run the scripts. Running the script now. Just tail that scripts. So here it is, the clearcache script is running. If you look at here, we have a 6-node cluster. HDFS has 6 good health servers. Yarn also has 6 servers here. Just checking this, it is showing that file which we are using here. We are going to create the files here. You can see that how much space is used when it's creating. So now it is in the progress. Before it's the PySpark, before the PySpark open, the application master is running in the background. So let's check it out in the resource manager. Running process, here the new process came up. And let's check it out. Spark job is running. It seems like it started. 239 jobs are started here. The jobs are working here. You can see the stages. 239 executors are working on. So we can also see that storage throughput. If you look at that here, here it's close to it's going close to 3.8, and sometimes here 4021 megabytes per second, and here it's also going 4057 megabytes per second. And I think when we started the process, we saw close to 5 gigabytes per second. So the A800 storage is almost busy for the write operations now for the in this particular volume. And what is the latency is going on here, as well as IOPS, all the details are available here. If you look at that, storage utilization is also available here. If you look at that total receive, it's going to close 5.506, it's more than 4 gigabytes per second. And total receive also is going to 3.29 gigabytes per second. It seems like a good amount of write has happened. Not great, but it's a nice read and write operations happening here. Write operations happening now. So the size of the data so far is a 2.1 TB is filled up. So we targeted for 2.4 TB data. Now is a 2.1 TB. Let's check it out in the space here. Storage is only for caching details, not for this. Cache data only available there. So far 17 minutes completed for writing this data. And here 2.2 terabytes of data copied so far. And I'm just refreshing the screen. So during this time, we can also see, let us see what is going on. Yeah, so here if you look at that, 238 job completed. So I think it's the last job is going on. Yeah, that is also completed now. So the total time to complete this write operation is 19 minutes 37 seconds. Time. So let me cancel that. So I will wait for that particular. Most of the time is completely busy, and there are some IO weightage during the time. So generally CPU is 100% utilized, so indeed it's almost busy. So now we have the report for the clear operations.